All right, so I know Jenna was having a problem with the other VM, so I'm gonna go ahead and upload this VM in case anybody wants it. But if you already have the other VM working, all you would really have to do is copy and paste all this code into seal.c. All I have in here are 4 functions, and then we have the main function. So the nonce function, all it does is initialize the nonce. It gets called a couple times, so I made it a function so I didn't have to keep on copying and pasting everything. But this is all, the exact code that they have in kmyth. All I did was copy and paste it. And then we have 2 other functions, but I'll talk about them later. And then this is create kmyth object, and I haven't really made any changes to how they implement create kmyth object either. As it is right now, pretty much everything works exactly the same way that their code works. It does not use the policy PCR. You can see I don't have anything, but if I go ahead and run the program, it will spit out the idk.ski file, and that is all encrypted ciphertext. But pretty much everything here at the beginning is the same as in the other video, so you can watch that for the details. I'm not going to go too far into it. We're creating a selection with all the PCR values that we're going to be sealing against, and then a bunch of hard-coded values. Most of this stuff up here is all variables that are pretty much all null. So it's a lot of initialization going on, but nothing else. Down here is where we get to the function kmyth seal, which is inside of the tpm kmyth seal and seal implementation. And again, I just brought some of that code into here rather than, having to go to that file and calling the function. But all we're doing is creating the SAPI context, initializing the connection, creating, this is for the owner password for the storage. So whenever they talk about owner, they're talking about the storage key, not the storage root key and not the wrapping key. Then they're creating objauth value. This is actually referring to the wrapping key, and that's going to be the password to access the wrapping key. Again, just creating a ski object. We're declaring that the default cipher is going to be the cipher that we're using. Just hard coding that stuff in there. This is Init Pcr Selection. Again, imagine we have 24 zeros, and if we selected PCR 0, then we would set a 1 here. If we selected PCR 2, we would set a 1 right here. If we selected PCR 1, this one would also be a 1. So whatever PCR we selected will have a 1 representation here, and anything we don't select will be a 0. This is all reviewed from the last video. This is the part where they actually call create policy digest. And right now, all I have is a copy and paste of what they had, creating a null command and response auth, which are needed to make a function call to the TPM. Here they're creating the variable that's going to hold the actual policy that we're going to be using. So in this case, we're going to be using a policy PCR. So once everything is all hashed together, it's going to get stored in that variable. So they create a policy session. They initialize the nonce using that nonce function that I talked about earlier. Then they do start policy auth session. They pass in a trial, and they pass in the address of policy session 1. And so that is going to be changing a bunch of variables on the policy session. So if I type in policy session 1 dot, not all of, but probably most of these details are getting filled in whenever they call start policy auth session. So for example, they're determining whether or not the session has salt. It's not going to be bounded. It's not going to be salted. It assigns the session type, which we see is going to be trial. But other than that, all it's doing is, kind of initializing the session itself. Then it does my apply policy, which is a function that's up here. So I'll look at that in a moment. We're passing in the context, the handle to the session that we created, and the list of PCR index values that we're going to be using. So go up here so I'm going to type foo so I can get back here quickly, and then my apply policy. This is the function call, command and response auth. This is taking in the policy auth value, which in our case, I don't think we're using one, but I believe that this is referencing whether or not we have an actual password associated with the policy session or the policy digest that eventually comes out. But by default, we pass it an empty digest with a size of 0, and then that gets passed into policy PCR. So looking at the actual TPM spec, if the length of PCR digest is 0, which in our case it is because we define the size to be 0 right here, it is going to extend it using this algorithm. So the new policy digest is going to be equal to the hash of the old policy digest, which presumably was all zeros, along with the PCRs with the bits corresponding to the unimplemented PCR set to 0, and the digest of the selected PCR using the hash algorithm of the policy session, which I believe is SHA-256. But again, up here, if we typed in policy session 1 dot, I believe auth hash might be telling it what type of hashing algorithm we're going to be using. and that gets declared whenever we do the start policy auth session. But coming back here, we're passing in the empty digest to the policy PCR, and it's going to store that information on the policy session handle somewhere. So now when we return from this function, here's where I called it. They call policy get digest. They pass in that policy session handle and the context and then the null command and response auths. And then we also pass in the digest, and it should be writing the actual output of that digest for the policy into policy 1. And then after that, they flush the context. So the session is not in the main memory of the TPM anymore. So far, all we've actually done was create a policy. We haven't created any actual keys or anything like that. So the next thing we have to do is get the storage root key handle. And if you actually go through and step through this code, there's a condition where if the storage key handle has not already been created, it will create one. But we don't really care too much about the details here. So I'm just going to go ahead and assume it successfully got the handle, and it's going to be storing that in the storage root key handle here. So now we come down here, we're calling the create and load storage key function. And here it is declaring that the storage root key handle is storage root key handle, which is this right here, which we modified when we called get storage root key handle. This is the auth val for the storage root key, the auth val for the storage key. Again, these are both passwords. We're not actually using them for our particular application. And then we have the storage key PCR list, which was earlier saved on ski.pcr list. And then we have the actual policy for the storage key, meaning that if we want to use any type of command with the storage key, we have to satisfy this policy. And this is the policy that we created right here. It was originally an empty digest, but after we did the apply policy and then the get digest, it will store that value in here, and it's just some hash value. Here they're referring to the actual storage key handle, which right now is going to be null. There's nothing in it right this second. And then this is going to be the private and public portion of the template when we create the storage key. Again, as of now, this should be empty. So now they're just initializing a couple variables. This is all basically doing setup to create the storage key. So we're setting a bunch of variables to 0, initializing them all. We're calling initialize kmyth object sensitive, and then it doesn't look like there's any real significant values being passed in here. Basically all of these at the moment are 0, although it should be creating that object and storing it in this variable right here. And then here tpm2b public, creating this template, and now we're initializing the public part of the object. So this was to initialize the private part, this is to initialize the public part. The private part is being stored here in sk sensitive, the public part is being stored in sk template. Do note that we have the sk auth policy, which is our policy 1, which is the same policy that we created using the policy PCR. And that is on the public part of the object template. So here they're creating a null session. So up until now, we still have not actually created the storage key. We're doing a lot of initialization. We're creating and initializing the template. We're passing in the session, which is going to be the session that allows us to use the parent key, which is the storage root key. So basically what's going to happen is we're going to call the create kmyth object function. And inside of that function, we have to satisfy the policy of the parent object in order to use some kind of action. Now in this particular case, the parent object, because we're creating a storage key, the parent object to that is the storage root key. So the storage root key actually has a null session because there is no policy associated with that authorization. Here we just again have a couple empty values that aren't important. There is no policy on the storage root key, and there is no PCR list value associated with the storage root key. Sorry, not storage key. And then the count of PCRs is going to be 0. So here they're actually calling the create kmyth object. Again, we have not actually created the storage key, even though we have done a lot of initialization and all that other stuff. All we've done so far is create the actual policy digest using this stuff up here. And then after that, we created the storage root key, unless the storage root key already exists, at which point all we did was retrieve the handle from the TPM. But assuming that this is the first time that you've run the TPM, you're creating the storage root key. But here we're just doing a bunch of initialization and then calling the create kmyth object. We're passing in all of these values, including the null session. And also note that we're passing in the sk template, which is the public part of the storage key, which has the auth policy on it, which is policy 1. that we created using create policy digest, that function. So let me write foo here and then create kmyth object. And this is pretty much a copy and paste of the code that they have. I just wanted to have it on the same script, so if I want to modify it later, it's a little bit easier. But like everything else, I got rid of all of the error handling. I cut out like half of the code because they have an extra condition for being able to create the storage root key. But I cut all that out of this part of the code because we don't really need it. Here they're initializing the response code to failure, and then later on they do a lot of error checking. I cut a lot of it out. So they have null command and response auth, and then they have a non-null one as well. Here they're initializing a bunch of variables, pretty much setting everything to 0 except for these items right here. This is specifying the hierarchy that we're using. Not entirely sure what the ticket tag is. I know it's in the book somewhere, but I still need to look at that. So they're doing create object command code. And then coming down here, if it is not create object auth session, basically saying that if the parent does not have a policy session or something associated with it, then that means that we're referring to the primary key, the storage root key. So note that we call this function create kmyth object 2 times. We call it, technically it does get called 3 times, depending. So when we do get, srk, I don't remember the exact function name, but when we do that get srk function, it will look in the TPM, try to find the srk. If it can't find the storage root key, then it will create one. And if it has to create one, then yes, it will call this same function, create kmyth object. Although the way that this function is written in kmyth, they actually have 3 different applications, which I personally wouldn't have written that way because it is a lot of lines of code inside of one function. But when they call create kmyth object, more or less they have something like if object you want to create is equal to the storage root key, then it does some code. Then it'll say else if object you want to create is equal to the storage key, then some other code, which actually that is this code right here. So it looks kind of like this. And then after that, it'll say else, and then it'll run all this other code, which is what you see right here. The main point being that the first time we call create kmyth object, we're creating the storage key. So we're running this code right here. Then we're skipping over all this code right here. This is where the else statement ends. And then after that, we run this code right here. So finally, we get to the point down here where we're calling create. And so it takes in the parent handle and pretty much all of the data that we've been accumulating so far. A lot of it looks like it's kind of empty. The main thing is that we have the object template, and this is the public portion of the template for the storage key in this particular context. And on that object template is where we have our policy. So here, after all this time, we're actually finally creating the storage key. And then here it tries a couple more times to create a storage key if that first time that we tried it, it failed. If it goes past, a certain number of tries, then it just gives up. And then here they have more code, create object auth session. This does not apply for this particular call because this is referring to that null session that we passed in earlier, but because we're creating a storage key, this code does not run. So then we return, and basically all we've done is create the storage key using this function right here. Now they're actually loading the storage key into the main memory, and we don't really care about this function. We can just assume that it was successfully able to load. So coming down here, this is where we return from create and load storage key, which is the function that we called. I believe it's inside of kmyth seal under the seal unseal implementation. So here's where they just clear out the owner auth buffer. And then this part right here, they're initializing the variables for the actual symmetric key. So they're getting the length of the symmetric cipher and determining the wrap key size. They're allocating the memory for it. Then they call the encrypt data function, which takes in the data, which in our case is going to be this file, which has IDK in it. And then it passes in the cipher and the wrapping key. And then after it does all that encryption, it's going to store that information on the ski.encrypted data and also take into account the length of the data. So both of those variables will be set on the ski object. I have stepped through that code. I don't think there's anything in there that actually matters to us. But we can call it and assume that, okay, now that we have made this call, all of that data is now encrypted, and we end up with our wrapping key. And this is the thing that we ultimately need to protect using the storage key. So here's where they call kmyth seal data. And I'm not a fan of the terminology here. I think it would be better if we said something like seal wrapping key, because that is what we're doing now. So far, all we've done is create a storage key. We created a wrapping key, and we sealed all the data that was inside of that file. And I think something I have said in the past, which is incorrect, is that, the stuff inside of the file is representative of the thing that we're wrapping, but it's not. So if I wanted to do a full disk encryption, I would probably come in here and call this function over and over, and every time pass in a different file. I'm going to put this back to sealed data because that is what it's called, and I want to be able to remember that for later. But just know that we're actually sealing the wrapping key, not the data. The data has actually already been encrypted using this function right here. So coming down here, inside of that function, they're passing a bunch of arguments. This is the wrapping key that we use to encrypt the file using symmetric encryption, the size of that key. This is the handle for the storage key and the TPM. And right now, that storage key should be loaded in the TPM at this point in the program. Then we have the actual auth value. Both of these should be empty because we're not passing anything in. But this is the auth value for the storage key. And then this is going to be the PCR selection for the storage key. And then down here, we have SDO, which is sealed data object. I prefer to think of this as, the actual wrapping key. So this is going to be the wrapping key's auth value, the wrapping key's PCR list, the wrapping key's policy. And you don't have to think of it like that, but that is how I prefer to think of it. Again, we're not using a password with the wrapping key. The PCR list is going to be the same for both the storage key and the wrapping key because they're both going to have the same policy where if we want to use that object, we have to satisfy the PCR constraint. So here we have the policy for the wrapping key, which is going to be policy 1, the exact same policy that we created all the way up here. So we used it for the storage key when we did the initialize object template here. And then if we come down here, you can see that we're doing initialize object template again, but this is for the wrapping key now. But this time we're passing in fdo auth policy, which is policy 1, the exact same policy. So basically the storage key and the wrapping key both have the same policy associated with them. So ultimately we're getting a sealed version of the wrapping key. And the only way to unseal that is if we use the storage key. But the storage key is also wrapped, or sealed rather, and that is being protected by the storage root key. So in order to get that wrapping key, we have to satisfy the policy that is written onto this sealed data object, they call it. But then we also have to satisfy the policy on the parent, which is the storage key. And this is pretty much like the same code that we had earlier. We're initializing the sensitive part of the key, which in this case is going to be the wrapping key. Then we create the template, and then we're initializing the public part of the key. Again, remembering that on the public part, we're putting on policy 1, so that information is going to be stored in the public area. Then here they're creating a session. Now the other one, the previous session that we created was a null session. This is not a null session. So if you come up here, you can see, again, they created the sensitive portion, they created the public portion, and they created the session, but they never actually call start auth session or create auth session. So they create a session, create a policy auth session, pass in the context. The details of this code might be a little important. I stepped through them briefly, kind of skimmed over them. It looks to me like they're just doing the initialize nonces, and then they're calling a start policy auth session, and then they're passing in the other TPM2 policy session or whatever it's called, rather than the trial session, which is what we created earlier when we were creating the actual policy digest. But we're basically declaring that this session right here is going to be a policy session to actually check the values of the PCR registers before we can actually do any type of action. We're not going to be able to do the TSS2 create, which is the thing that allows us to seal this wrapping key. We can't execute this function if we can't satisfy the constraints of the storage key, the policy that was already written into it. So again, this is the same function we called earlier, but this time we don't have a null session, but we are once again passing in the handle to the parent, which is the storage key in this case. Previously, the parent was the storage root key, and then this is the auth value and PCR list associated with the parent. This is going to be the information associated with the wrapping key, including the public template, which on that public template, we have the auth policy, which again is policy 1. So coming back to the function, Here we're calling create kmyth object again, initializing the null command and response auth. This is actually a different pair of response auths. So again, creating and initializing all these variables, most of which look to be null. There are a couple others. Creating the command code. Here this is saying if not create object auth session, this does not apply, so we're going to hit this else statement because this only applies if we have a null session. So here we're doing apply policy. I think this is one area that we have to modify because right now it is doing a regular policy PCR. So let me just write foo modify me. But then after that, it creates a session digest, and then it will get the get digest, read public, create prepare. I don't know what all these do. We would have to go through and look up the documentation for each one of these functions in order to really know what's going on. Get command code, command auth. After it does all of this code, which I don't know exactly what it does, it comes down here. This is the same code that we hit when we were creating the storage key, and it does the TSS to create. It tries to create that object, and then only if there is a create object auth session, it will check the response auth. And I think ultimately this is just a way to make sure that the values in the PCR registers are actually matching up with the values that the TPM has on the policy 1 that is associated with the storage key. And then finally it returns. And then after that, nothing really interesting happens. I think we were right here. We created the kmyth object. We flush the context so we get rid of that session from the TPM. We do a lot of garbage cleanup. Create the ski bytes. We free the memory, free a bunch of other resources, and then we write all those bytes to the file which gets outputted. And then that is it. So theoretically, what I think should be a solution, and I've had an issue with implementing it, coming back here, this is the part where we actually create the policy digest. And this is the policy that ends up getting put onto both the storage key and the wrapping key when we create them. So the first thing I've done was basically copy and paste all of this code right here, because this is, the code that they already have for a policy PCR. So I haven't done anything different, literally just copying and pasting. I did change the name of all the variables, so instead of policy 1, it says policy 2. But once again, we are creating a policy, declaring the size as 0. This is our nonce function, passing it in. This is a trial version of the session. All of the settings are exactly the same. We do myApply policy. We get the digest back and we store that in policy 2. And then we flush it. And again, the way that kmyth works right now, it says if PCR values are equal to current values, then it will do the seal successfully without any problems. But what we're trying to write in is if the PCR values are equal to the current values, or if PCR values are equal to the future values. If either one of these conditions work, then we want to unseal and be able to seal when we create everything. But what I'm trying to do, at least as a workaround temporarily, is say, if PCR values is equal to current values, or if PCR values is equal to current values. Because I'm assuming that, this condition is true, and there's no reason it shouldn't be. And if we can make this work, then, we can make the next logical step of, okay, now how do we get this and how do we put that into here? So right now, that's why I've copied and pasted this code. I'm not doing anything custom or different. I'm just copying and pasting policy 1, policy 2, and then flushing both of them from the TPM. And then the next part is to actually write in the policy OR, which I do down here. And a lot of it is very similar. We're creating another TPM2 digest. The size of it is going to be 0. And then we have the TPML data type hash list. So this is going to be an object that contains all of the hashes from policy 1 and policy 2. And then creating a new session. We're creating another nonce for that session. And then here we'll do start policy auth session. Pass it in the policy OR. Again, so far we haven't done anything unique other than create this object right here, which right now is empty. And then here I do the apply policy OR function. So if I just type foo here and then do apply policy OR, and I come down to this function here, we're taking in the context, we're taking in the handle of the session, which is, a normal session like all the others. It is a policy session. We're taking in the actual policies that we created already, policy 1 and policy 2, and then we're taking in that TPML digest object, creating creating another null command and response auth. And then on the policy hash list, we're setting the count to be 2, and then we're setting the digest 0 to be equal to the hash value of policy 1, and the digest of 1 to be the hash value of policy 2. And then we're doing the policy or on them, taking in the handle, the context, these null command and response auths, and the actual hash list itself. And then when that is done, we come back where it says foo. All we do is get the policy digest from that session, put it in the policy or. So now this TPM2 digest up here should be the new policy digest that handles the or functionality. And then we flush the session from the TPM. So now instead of policy 1, and I'm going to comment this out real quick just because it should hopefully highlight the dependencies. So we can see here we have policy 1 and policy 2. That is fine. We want that there. But if I come down here, you can see I have policy 1. I want to replace that with a policy or because this is going to be the storage key policy. And then if I come down a little bit further, this should also be policy or. And I believe those are the only 2 spots where we need to pass that in. And we're not referencing the session anywhere, so I can uncomment all of this. So now we have created the policy or, and that digest is in policy or. And so here again, we're doing what we did before. We're creating the storage root key. We do the get SRK handle. If they can't find the storage root key, it actually creates one. And then we come down here. We are creating the template for the storage root key. We're passing in that auth policy, which is now the policy or. We're passing in a null session. And here I'm doing the new create kmyth object, passing in the null session and the SK template, which is the public part of the template that has the policy on it. So we can go ahead and write foo here. New create kmyth object, find where that was defined, and coming down into the code. And again, remembering create object auth session in this particular context is going to be null, and the policy that we are referencing should be on the public part of the template here. So again, a bunch of initialization coming through. We should hit this block right here. It does the init password command auth. I don't think that has anything to do with the policy session. We do not hit this code because we're creating a storage key at the moment. It does hit this code. It tries to create the storage key using all the data that we fed it. And then we do not hit this code because our create object auth session is going to be null. So then it returns. And so we'll go back to foo. And then here we're going to actually load that storage key, not changing anything in the code. Everything should be working correctly. Again, it does the kmyth clear for the owner password. It creates the wrapping key or allocates the memory for the wrapping key. Then it does the encrypt data, takes in all of the data from the file, encrypts it all. And then here we call the kmyth seal data. And this is again going to be the wrapping key. We're going to be sealing that with the storage key. So we have to pass in the parent, which is the storage key, and then the wrapping key itself, the item that's being sealed. And then we're setting the policy. In order to unseal that is going to be the policy or, the same as it is with the storage key. So again, a lot of this code is the same as what we talked about earlier. We're initializing the sensitive part of the object. We're passing in the auth policy, which again is policy or. Now this time we are creating a sealed data session, and then we are creating a create policy auth session. Now again, I think all this does is create a normal start auth session. We may have to dig deeper into this function because I don't think it references policy PCR anywhere, but it might. And if it says, the type of policy auth session is referencing a policy PCR instead of a policy or, we would have to change that. But I'm going to go ahead and pretend for now that works fine. If, everything else does not work, then that'll be the next step to look at. All right, so here we're creating a kmyth object, passing in the session, which is not a trial session. This is a real policy session. And then we're passing in the handle for the storage key, the auth value, the PCR list, and then all that same information for the wrapping key, including the, template, which has that policy on the public area. Drop a foo. And then here, one more time, new create kmyth object. We do all this same stuff again. This time, we do not hit this if statement. We hit the else statement. And then it does an apply policy. The problem is that this is definitely going to be referencing the policy PCR. All right, so we do need to modify this. I'm going to play around with it because it's a little more complicated than copying and pasting the code that we already have because they've already created a session and passed it in. But ultimately, then we should be able to do the policy get digest. And then we come down here. It creates the actual object. And then here it's going to actually try to validate the TPM response. And I believe that just kind of confirms that everything worked correctly. But ultimately, this section right here where we're doing the apply policy should look very similar to what we have down here, which is create policy digest, but within that we had another apply policy. This was the apply policy, but before that we had to create a session, initialize the nonce, and they've already done that for one of the sessions, but we actually have to have 3 different sessions, and I'm going to mess around with the code a little bit and see if I can get something working. All right, a couple of notes. I went back, I modified the code, and it still doesn't work, of course. These are the errors I'm getting. The problem is number one, these errors are not coming from the TPM. They're coming from kmyth. So we're not really getting any good feedback about why anything is going wrong. Number two, these are the same errors that I've been getting. If I, handle my policy sessions incorrectly, I end up with the exact same error. Where, if I forgot to flush one of my sessions, it will give me this exact same error. But in this particular context, I don't believe I have forgotten that. This is the code that I modified. It looks very similar to what we had before. Creating the policy, digest, defining the size as 0, creating a session. So instead of doing the nonce function and doing like a start auth session, I used the create policy auth session. I have tried both methods. Neither of them works. But this is basically doing create policy auth session. And again, we need to dig into this a little deeper just to make sure that there's nothing in there that would hinder us. The next thing I did was my apply policy, which is really nothing more than policy PCR. We're taking in that handle. We call the policy get digest, store that digest in policy 2, and then we flush the session from the context. And we did the same thing up here for policy 1. So far, nothing interesting or different. Again, creating another hash list for the policies. This time I did policy or the same policy or as before, taking in the context, taking in the handle, policy 1, policy 2, p hash list. And then creating a session digest, which before, I called policy or, but this is what they called it in kmyth. I left the name alone. But it is referencing this session, which is the one that got passed in. So you can see I didn't create a new session for the policy or. This is the one that got passed in. And in the context of the original version of kmyth, this function policy get digest looks exactly the same, because they're using the session that they passed in. This is going to be the output session digest, taking in the null command and response auth, and then continuing down toward this code that I don't really know what it does. There's a lot of it, and then coming back, more code. Again, creating the actual object itself. The policy should be stored on object public here. I'm actually not sure where they reference session digest. It doesn't actually look like it gets referenced. So I need to look a little closer at the code, make sure that makes sense, because they definitely call this and then they store it in a policy get digest. Maybe they did that outside of this function, I'm not sure. But coming on down here, they do a TPM create if they have the create object session, which in this case we do. It is checking the response with all of these response auths. And then that is it. So coming back out, this is the return call. This is the point where they finally flush the field data session, and then they clear away all this information. So I'm not entirely sure in the context of regular kmyth what they do with this, if they do anything at all. I'll have to look into that. One other thing I did want to note, looking at real quick the policies in the policy or, if I come down here, this is past the point where we store the values of the policies in policy 1 and 2. I'm just going to run the debugger real quick. So if I come down here to policy 1, take this with a grain of salt because I feel like I've been seeing these numbers everywhere. Maybe I'm imagining it. But if I go to show in memory view or control enter, it shows me that this is our value inside of policy 1 buffer. And if I come back to policy 2, again coming to the buffer, they appear to be the exact same thing, which is good considering what we're trying to do. So I guess this section right here is referencing policy 1. And then this section down here is referencing policy 2. But they are the same, and that is a good thing because we want them to match, right? And if I come back here to the point where we're actually creating the kmyth object, and inside of the function we're calling pretty much the same code, and we come down to the policy or, and if I run the debugger here, I believe that if we come down to the buffer and if we show in memory view policy 1 buffer and policy 2's buffer, so policy 1 should be here. Again, these look like they all match, which is all good. So I don't see why this wouldn't work if they are in fact deterministically coming out with the same policy digest after doing the whole policy PCR. So, I mean, it is highly possible that I've done something wrong inside of the apply policy or function. Not entirely sure what it is, but we have a command and response auth. These are both null, so I don't know that we can do that. Maybe try passing in the other variables instead. I'll mess with that and see if anything improves. But other than that, I'm not entirely sure. But obviously, it still doesn't work.